Difference of squares. So we have an expression here. There's a quick way to do this, but one of the problems with this is recognizing that you have a difference of squares. Now, in the name, it's supposed to help. The idea is a difference is a subtraction, and there's actually only two terms involved. Okay, so visually, when you're looking at a factoring question, that can sometimes be a giveaway. Hey, I got two terms. This is probably a difference of squares. If there's subtraction, we're probably 90% sure it's that way. The real application of this is in a real quadratic question or a question we're dealing with a complex algebra. Noticing a difference of squares can be tricky. So what we'll do is we'll go through the method for it, and then we'll relate it back to like that crisscross method, and I'll show you that one. And then realizing in a harder question like this that you're dealing with a difference of squares rather than a crisscross method will be helpful. So we take a look at the first one. We have two terms, okay? And we have a subtraction term in between. So to test for a difference of squares, we take a look if we can square root. So I'm going to take our first term, which is 9x squared, and the question is, can I square root this? This can be written as the root of 9 times the root of x squared. Okay, and we find the square roots of both. Well, square root of 9 is technically positive or negative 3, but in this case, we're always going to use the positive value when we're doing the factoring. Okay, square root of x squared is just x. So the square root of 9x squared is 3x, and that makes sense. If I quickly, do a side of the envelope calculation, 3x times 3x, 3 times 3 is 9, x times x is x squared. There you go, that worked out. Other value. I'm going to ignore the negative because I'm not finding negative roots. That's a very different type of mathematics. I'm just looking for the root of 25, which in this case is 5. Awesome. Once I have that, both those terms are the first and the second term in each bracket. So 3x is the first term in both. 5 is the second term. And the only thing we have to do is make sure we have a plus and we have a minus. And that's it. That's a difference of squares. I could, I'll quickly show you this crisscross method. Because we're used to trinomials, which means 3 terms. Right now, we look at this, I have 2 terms, okay? And what's normally missing? Well, I'm used to looking at like an x squared and an x, and then some constant known as the c value. So you have like an ax, bx, and a c. What we can do instead is, hey, take a look. I got an ax squared, that works, and I have a constant there. I'm missing my b value. Well, I can just make my own up. I'd have to represent nothing. So instead, what we do is we represent it with 0. We have 0 x's. The only purpose of that is to help us, I don't need C, with our algorithm. Whether we're using decomposition, crisscross method, whatever it is, we can now use this. So I find factors of 9. So we go 1 and 3, not 1 and 3, 1 and 9, 3 and 3, 1, 25, and 5 and 5. Now, if we quickly take a look at this, I got to make a 0, which means I got to add and subtract my values here. So I'm going to have 15 and 15. One of these should be negative. Positive 15, negative 15 gives me my 0x. And then what is that? That becomes a 3 in each. I kind of sped through this piece. And then we have a negative 5. There's an x. Negative 5 in one and a positive 5 in the other. Okay. Don't have to use that method if you can figure out the difference of squares. What about a harder question here? As long as we have our 2 terms, a difference, let's try our difference of squares. Square root of 16x to the power of 4. I'm going to split it. Root of the coefficient times the root of whatever the variable is. Root of 16 is 4. Square root of x to the power of 4. That's a little trickier. What you're actually doing is you're going to divide the power by 2. So if it's 4, we bring it down to 2. Okay? And then you could test that again. Little side of the envelope calculation. 4x times 4x squared. 4 times 4 is 16. And if you remember our exponent laws, our base stays the same and we add the 2 exponents. So that becomes 16x to the power of 4. That worked out. So now that we know that trick, we do the same thing with the second term. 81y to the 20th. Split them. Let's find the root of the coefficient and the root of the variable power. Root of 81, do some thinking. I end up at 9. This one, we just half the power, whatever the power is. So this becomes y to the 10. Once we have these 2 terms, we build our 2 brackets. First term is 4x squared in each. Second term is 9y10. 9y to the power of 10. And then we just have an addition and a subtraction. And we've now solved using our difference of squares for both questions.